This is GMAETS 41. You're welcome to our introduction to calculus. In this video, we're going to look at the topic coordinate geometry. When you hear the term coordinate, what comes to your mind? You start thinking about maybe the plot of a graph where you use certain coordinate of x and y to locate a point in a plane or even in a space. Let's think about in a plane 2 dimension, in space 3 dimension, just like we have learned from physics. Now, in talking about coordinate geometry, we encounter concepts of Cartesian coordinates where we use the x and y axis. And then we also encounter the concept of polar coordinates. We also have cylindrical coordinates. We're going to focus on Cartesian coordinates. And what are the things you're expected to learn from coordinate geometry? We'll have them listed on the board here. The distance between 2-point formula, very important, and the calculation therein. We'll tell you about the midpoint of the line. If you're given a line, how do you obtain the center? The coordinates of the midpoint. We're going to look at it. We're going to talk about internal and external division of a line. We will look at the equation of a straight line, the equation of a normal line, also called perpendicular line, and then we'll talk about the equation of the tangent to a curve. It could also be a tangent to a circle, alright? Although in our previous classes in calculus, that's differential calculus, we've looked at the concept of equation of tangent to a curve. Briefly there, okay? Alright, now we start with distance between 2 points. Imagine that you have these 2 points in a plane. Look at point P and point Q, located with the coordinate x1, y1, and then x2, y2. You are asked to find the distance, alright? The length between these 2 points. What are you expected to do? If you look at this, with this right angle triangle drawn there, you will agree with me that one can think of the concept of Pythagoras rule to work that out, which states that the square of the hypotenuse is equal to the sum of the square of the opposite and the word adjacent. So what do we do? How do we get the opposite here? The opposite, which is the y-axis, is simply y2 minus y1. And then the adjacent, which is the horizontal axis, is x2 minus what? x1. And so if you apply Pythagoras rule here, you will notice that pq squared will be equal to y2 minus y1 squared plus x2 minus x1 squared. And then to get your pq, you take square root of what? Both sides. And that is why the distance pq, which is called the distance between 2-point formula, is given as square root of y2 minus y1 in bracket all squared plus x2 minus x1 in bracket all squared. The x may come before the y, you commit no crime, of course, it's addition here, you know that. Now we quickly want to look at the midpoint formula. Imagine that you have a straight line, PQ, and I want to locate the coordinate of the middle, the midpoint. So what do you do? Alright? To obtain the midpoint formula, this is the formula you use. To get the x coordinate, it's x1 plus x2 divided by 2. To get the y coordinate is y1 plus y2 divided by what? 2. That is what is pressed out here. Don't forget also that in this topic we are going to treat collinear point as well too. In the next video we are going to look at internal and external division of a line, the equation of a straight line, and the rest of them. Let us now talk about internal division of a line. Previously we established the midpoint formula, right? The midpoint formula is extended in a way into internal and external division of a line. In terms of the internal division of a line, in fact, the difference is that the ratio into which the point R divides the line PQ is no longer 1:1. In midpoint, it was actually 1:1, although we didn't discuss anything about ratio division in midpoint. But actually, the midpoint in that formula divided the line PQ into 2 equal halves, where K is 1 and L is 1. Is that clear? That is why it did not reflect there. In this case, for internal division, the point R now divides line PQ in a given ratio K is to L, where K is to L is not 1:1. It's not. If it is 1:1, then it means that point R is actually a midpoint of PQ. Take note of that. Now, in the case of internal division of a line, what is expected? Similarly, to get our x coordinate of point R that divided line PQ, watch how you go. It's going to be this ratio times x1. You're going to use the x coordinates to get your results, plus this ratio k times x2. Look at it. Then divide everything by L plus k. That is the sum of the ratios. Then to obtain your y coordinates, what are you going to do? You use your y coordinates of the line PQ. Use it to get the y coordinates of the point that divided that line PQ. So to obtain our y, you move again. It's going to be L times y1 plus k times y2. And then divide by what? L plus k. So that's the formula. Is that okay? If you take note of this, it's similar to midpoint. The only thing that the midpoint, L is 1, k is 1. Just substitute it here and you see that this will give you midpoint formula exactly. But take note for internal division, the point that divided the line internally is not into a ratio of 1:1. Take it. Alright, so you need this formula, memorize it. Now for external division of the line, what do we need? It's still similar. In external division of the line, a point R divides that line externally. Is that okay? I know you might be wondering how possible you have a line and an external division. Well, that's not what we're talking about. But in the case of extension, when you project or that's produce the line. Now for the external division, we'll have this R dividing line PQ externally at this point. So we want to get this x, y coordinate of the point that divided it. Now the formula is similar to internal division, okay? So I'll allow you to go through it. The only difference is that in this case, numerator and denominator is what? Minus. Then take note that the way L and K is arranged in the denominator matters. It is L minus K, not K minus L. Take note, although depending on how you arrange this. So following my own arrangement here, the denominator is always L minus what? K, not K minus L. When we come back from the short break, we're going to look at gradient of a straight line and other things about equation of a straight line and tangent of a line. We now direct our attention to gradient of a straight line. On the board here, we have it. We're going to use M to represent the gradient of the straight line. So we have line PQ, alright? We want to get a gradient. The coordinate of P is 0, x1, y1. Coordinate of Q is x2, y2. Now, how do we obtain gradient? First, you need to know that gradient is the same as slope, alright? So what do? Just remember how you take the slope of a graph. So this is the line PQ. We're going to draw the horizontal and vertical line to meet at 90 degrees. And then to get the slope, you recall that is changing y over what? Changing x. So look at it. Gradient is equal to y2 minus y1. Then all over x2 minus what? X1. You've gotten your gradient. Now take note that there are other ways you can obtain your gradient depending on the information given to you. Suppose the line PQ makes an angle theta with the horizontal. One can still get gradient from simply obtaining tan theta. That is tan of the angle that the line made with what? The horizontal. Again, one can obtain gradient of a line from differential coefficient of a given equation of a curve. Let's assume that an equation is given to you, and then that equation is not the equation of a straight line per se, and you are asked to find the gradient of the straight line from there. All you need to do is to differentiate that equation, then substitute the point x1, y1 given to you in the problem. We encountered something like that under differential calculus, yes, in our previous videos when we treated differentiation. So that could quickly help you get to know what we are talking about here in terms of using dy dx at the point x, y to obtain your gradient. And this moves us to gradient of a perpendicular line. I'm using this symbol, call it M perpendicular. Generally, gradient of straight line times gradient of perpendicular line is equal to minus 1. And so if you make gradient of perpendicular line subject to the formula, it's going to be minus 1 divided by what? Gradient of the straight line, M. So all these formula, you need to memorize them. What about the equation of a straight line? We pick the general form. First, there are other forms of equation of a straight line, depending on the information given to you, but we are picking this one first. Subsequently, as we work in this, we're going to solve problems on other forms. Now the equation of a straight line is simply given as y minus y1 equal to m x minus x1, where m is gradient. Is that okay? In the given problem, the value of y1 and x1 likely will be given to you. So all you need to do is to calculate your what? M, gradient of the straight line. Then you solve this equation, alright? Your result will contain y and x. In fact, by the time you are done solving everything, your result will look like this. Because this equation is called equation of a straight line in slope intercept form. This is the slope and this is the intercept. If you work around this equation, you get this. Now, how do we actually get this intercept from here? The intercept term is actually equal to minus, okay, our c is actually equal to minus m times x1. That is this m times this x1. You give me minus m times x1. Then this minus 1 crossing over, giving us plus 1. So this term is actually our what? Intercept from there. Anyway, take note of this equation. That's what you need. And then we have equation of a normal or perpendicular line. It's still similar to the equation of straight line. The only difference is that in this case, you're using what? This. That is gradient of the perpendicular line. Don't forget that from here, your m is equal to what? y2 minus y1 all over x2 minus what? x1. We now direct our attention to all the useful forms of equation of a straight line. We've considered the general form, alright? Now let's look at the case. Imagine you have a straight line, and that straight line made an intercept with x and y axis. How do you obtain the equation of that straight line? Is that okay? This a and b are the intercepts on the x axis and on the y axis respectively. Is that okay? Now to get the equation of this line PQ that made this intercept on both axes, look at the formula. It's going to be x divided by a, the intercept on the x axis, plus y divided by b, the intercept on the y axis. Everything equal to what? 1. So you have to memorize this equation as well too. Then again, we want to consider the form of equation of a line such that there is a perpendicular distance from the origin to that line, and the length of that perpendicular distance is being given to you. Look at the diagram to get what we're talking about. Now this is your y and x axis. Now we have this line, let's say line PQ, alright? Then this is a perpendicular. Look at this line from the origin. This is the origin, point O. Now the perpendicular is this line from the origin. Look at it. Now the length of the perpendicular from the origin touching line PQ, the length of the perpendicular is given as P. And you notice that the perpendicular, alright, made an angle alpha with the x-axis. Take note that this angle as a whole from the origin here is 90 degrees because this is a vertical line y and a horizontal line x. So out of the 90 degrees, the perpendicular whose length is what? P, made an angle alpha with OX axis, that is the horizontal axis. Now how do you determine the equation of this line PQ? That's the point. Now to get the equation, look at the formula. It's going to be x times cos alpha plus y times sine alpha. Everything equal to P, P being the length of that perpendicular line from the origin to the line whose equation you are looking for. The next thing we want to look at, having considered these two important forms of equation of a straight line, we now want to consider the angle between two straight lines. Imagine that I have these two straight lines and they intersect. How do you get the angle between them? Alright, now imagine that you have the straight lines to be these equations, y equal to m1x plus c and y equal to m2x plus c. You know, these are the standard equation of a straight line. You have to calculate the angle between these two lines. So the formula you use is this: tan theta equal to m1 minus m2 all over 1 plus m1 times m2, where these m's are the gradients of the line. If you look at this equation and you have a good knowledge of the trigonometry, you'll agree with me that this is the trig identity for tan theta, where theta is equal to sum of two angles, let's say a plus b. So that's where we actually derive this equation from. Now to get your theta, what do? All you need to do is to take tan inverse. Is that okay? You can see it. So this gives us the value of the angle between the two straight lines. We now want to look at how we can obtain the area of a triangle given the coordinate of the vertices. That's the point where two sides of a triangle meet. You have the coordinate, you can see that at point Q you have x1, y1, at point R you have x3, y3, at point P you have x2, y2. After analyzing this, using the concept of what we know about area of triangle, which is half base times height, I came out with a principle I call the Omak's clockwise perpendicular drive principle. Now what is it all about? How do we use this formula? So quickly look at the board as we walk through it, okay? Remember, clockwise perpendicular drive principle, which means you should take note that you're moving in a clockwise direction, and at every point in time, make sure that you take note, you recognize the perpendicular to your direction of drive. So we go, area of triangle PQR is equal to, you start from any point, it's your choice. The same as I've decided to start from any point. I'm starting from this point Q that has x1, y1 coordinate. I chose those coordinates, I defined them. So if a problem is given to you, you select the one that is x1, y1 is your choice, okay? So we go about it. That's equal to 1 over 2 times, this 1 over 2, the normal thing about triangle, half. Now base times height. We start from here. How do we get the base QR? It's going to be, I'm using x1 minus x3. Look at it. Times the perpendicular height to that side, to that base. Because this is the base here. The perpendicular height now is y2 because that comes from this point P. Are you following? Then touching the base, x1 minus x3 that I've just analyzed. So this is your y2, the perpendicular height. Then we move on. Remember, I've driven to this point. So I'm moving from this point R now to point what? P. So it's going to be x3 minus what? x2. So you get another base here. Then multiply it by the perpendicular height to that base. And the perpendicular height to base PR is that which comes from what? Q. And that which comes from Q is y1. You can see that, right? So this is it. Then plus, I'm now driving from P to what? Q. So we're going to have x2 minus what? x1. You can see that as our third base. Then multiply by the perpendicular height y3. The perpendicular height to this base PQ is that which comes from what? From point R, which is y3. Good. And that's how we go about this formula. Quickly, how do you get whether a point is collinear or whether points are collinear or non-collinear? And you see this note here. If you have 3 or more points being collinear, then picking 3 points from there and you solve the area of the triangle, you're expected to get what? 0. But if they are non-collinear, if you solve the area of the triangle using this formula, you won't get 0. Then you can say that they are non-collinear. Now I want to conclude with coordinates of point of intersection of two loci. Imagine you're given an equation of straight lines or maybe curves and they intersect. You are asked to obtain the coordinates of this point of intersection. What do? Simply quickly solve the simultaneous equation using these two equations given to you. Obtain your x and y, and that's the coordinate of that point of intersection. We have this question and the board, question 1 here, okay? The distance between the points 1, 3 and 5, C is root 41. Find the two possible values of C. Now, we are to obtain the two possible values of C, given that the distance between these 2 points, 1, 3 and 5, C, is root 41. Now, if we take it as, okay, let's point A be equal to 1, 3, and then point B be equal to 5, C. Now, the distance between AB, distance AB is equal to root 41. Now, you recall the distance between 2 points formula. These are the 2 points. we have the distance between 2 points. Let's say A, B is equivalent to square root of y2 minus y1. You square that plus x2 minus x1. You square that. Now coming to these 2 points, these are x1, these are y1. At point B, these are x2, this is our y2. Okay, so we can substitute these values into this formula. The distance between point A, B is root 41, so we're going to write root 41 equal to square root y2 is c minus y1 is 3. I'm going to square this value. x2 is 5 minus x1 is 1. I'm also going to square this. Now this is going to give us square root of 41 equal to, what out this, you have square root, this is c minus 3. We're going to square that, then plus, this will give us 4. 5 minus 1 is 4. 4 squared is 16. Now at this point, what we are looking for are the possible values of c. And you notice that this c is covered with square root sign. So what we're going to do is to remove the square root so as to leave this expression open in order to find a way to make c subject to formula as the case may be. So we're going to take square of both sides to remove this square root. So if I square both sides, squaring this term that has square, the square root will disappear. So we're going to have 41. If you take square of this whole term, you have brackets and then you square it. That square will remove this square root. So you're going to have c minus 3 all squared plus 16. Does that make sense? Now this term can be expanded. If you expand it, the first 16 should come over here. If 16 moves to this place, you have 41 minus 16. And 41 minus 16 will give us what? About 25, right? Equal to, I'll come to c minus 3 squared. I'll expand this. You can expand it by doing c minus 3 times c minus 3, okay? If you work out that, you will get c squared minus 6c plus 9. That is what you're going to get. Now watch something. If I move this 25 to this right hand side, it's going to be c squared minus 6c plus 9 minus 25 equal to 0. Is that not so? Look at it. C squared minus 6c. This 25 going over there, we have 9 minus 25. And 9 minus 25 will give us minus 16. Everything equal to 0. We can now solve this quadratic equation to obtain the possible values of c. Let's do that and see. To solve this quadratic equation, we're going to look for 2 factors of minus 16, which if you add, you get minus 6. Now what are the 2 factors which if you multiply, you get this 16 minus 16, and if you add them, you get minus 6. You agree with me that the factors are going to be 8 and 2. So you now check how to arrange the 8 and 2. The 8 will carry negative, and then the 2 will carry what? Positive. So once you add them, you get minus 6. So the factors are c minus 8, and then c plus 2. Okay? Equal to 0. You can now solve. You notice that from here, if you equate it to 0, c will be equal to 8. From here, if you equate it to 0, c will be equal to minus 2. So the 2 possible values of c here are minus 2 and 8 for this problem. Question number 2. P, 1,5 and Q, 2,8 are 2 points on the Cartesian plane. Find the equation of the straight line PQ. So you look at this problem, we are already given 2 points PQ. So at point P we have 1,5, because you know this is x1 and this is y1. Then point Q is located by the coordinates 2,8. This is x2 and this is what? y2. We have to find the equation of the straight line PQ. You know the equation of straight line PQ given 2 points, alright? That is the line joining these 2 points is obtained from y minus y1 equal to m bracket x minus x1. This is the general equation of the straight line, you know that, right? Given some points. So the points that we are going to consider as x1, y1 are these points here, you know. Now our problem is to obtain the gradient of this straight line first. And that's why we have these 2 points, okay? So with these 2 points, we can obtain the gradient of the straight line. Or we can say that you know that this gradient m is y2, okay, let's substitute this y minus y1 equal to m here is y2 minus y1 all over x2 minus x1. You know, this is the formula for calculating gradients when you have 2 points. Is that so? So you're going to multiply by x minus x1. So substituting, this is y minus y1 is 5 equal to y2 minus y1 is y2 minus y1, that's going to be 8 minus 5 all over x2 minus x1 will give us 2 minus 1 because x2 is 2 and then x1 is what? 1. So from here we're going to get our gradients, then x minus x1. x1 is 1, right? Good. Our problem is solved. The remaining thing here is just to simplify. And so if we're working further, this is y minus 5 equal to 8 minus 5 is going to give us what? 3. And so we're going to write 3 all over the denominator. 2 minus 1 is going to give us 1. And then x minus 1. Of course, this will give us y minus 5 equal to 3x minus 3. You know, when this 3 opens up the bracket, 3 over 1 is already 3. So this is our result. We can collect terms together. I might choose to make y subject of the formula so that it will be equal to 3x minus 3. If this minus 5 crosses, it becomes plus 5. You add it to this minus 3, right? So if you have minus 3 plus 5, it's the same as 5 minus 3. And that will give us what? Plus 2. So this is the result in standard form, okay? Or you may see the result in this form where everything is collected together, okay? and then equated to 0. You notice what I did here? 3x and 2 crosses to become minus 3x and minus 2. So everything equal to 0. So either of these can be taken as an option, the solution to this problem. Let us look at this question number 3 on the board. We have to find the equation of the line drawn through the point of intersection of the lines 3x plus 2y equal to 3 and 5x minus y plus 8 equal to 0, which also passes through the point 2, 2. Now if you look at this problem, you would recall what we said in our previous class, that when two loci intersect, you can obtain the coordinates of the point of intersection by solving a simultaneous equation. Did you remember that? And that will help us to get the coordinates of the point of intersection. Let's just quickly look at this. Imagine that these are the two lines, alright? Now, this line is defined by the equation 3x plus 2y equal to 3. We can also define this line as 5x minus y equal to minus 8 if you take this 8 to the other side of the equation. Now, this is the point of intersection. Let us represent the coordinate as x, y. Is that okay? Now, there is a line that passed through this point of intersection. Let me draw another line. Let this be the line whose equation we are looking for. It passed through this point. And somehow, some way, this same line passed through another point. Let's say that this is the point where it still passed through. And at this point is given as 2, 2. So let us take this point as x1 and this as what? y1. Which means that this coordinate of point of intersection we are about to obtain so as to get the equation of this straight line. That this coordinate will be taken as x2 and this one as y2. Now what are we going to do? We will first solve a simultaneous equation using these two to get this coordinate point of intersection. And then we now get the gradient of this line, use it now to obtain the equation of this line. So it's pretty simple, okay? So let's move on. I am going to solve, say that 3x plus 2y equal to 3, let this be equation 1. And then 5x minus y equal to minus 8, let this be equation 2. I will solve these equations simultaneously. I'm going to use elimination method. Now, I have decided that I will eliminate y from this equation. Now, to eliminate y from this equation, the coefficient of y in equation 1 and equation 2 must be equal in size, that is in value. Now, this is 2y, so I will find a way to make this y here 2. And this is 1y here, is that not so? So what would I do to make this 2y? Simply, I'll multiply equation 2 by 2. If I do that, this becomes minus 2y. Is that okay? So, I would have these, and then let me bring down 3x plus 2y equal to 3. Okay? And then, to get this coefficient to be the same as this, I want to multiply this equation by 2. So, I'm going to have 10x here, that is 2 times 5, coming over here, minus 2y, then equal to 2 times minus 8 is minus 16. So, this equation is actually obtained from equation 2 times 2. So, at this point, I will do a subtraction, and addition. I will add. The reason is because I want to eliminate y. When you have different signs, you add to eliminate. If you have the same signs, like this positive or minus minus, you subtract to eliminate. You can note this down, please. Different signs, you add to eliminate. The same signs, you subtract to eliminate. So I'm going to add this. This will give me 13x. 13x. Then if you add 2y plus minus 2y, it's still the same as 2y minus 2y, because plus times minus is minus. So this will be eliminated to 0, 2y minus 2y is 0, because you don't need to even bother yourself here, trying to work it out. That was what you saw that made you manipulated something, by multiplying equation 2 by 2. So already this will be eliminated. Come over here, 3 plus minus 16, the same as 3 minus 16, because plus times minus is minus. And 3 minus 16 will give us minus 13. Divide both sides of this equation by the coefficient of what you're looking for. You'll see that x is equal to minus 13 divided by what? 13, and the value of x is minus 1. So I will not use this value of x to obtain the value of y. I will use this equation 2, it will be faster for me. If you want to use equation 1, it's your choice. If you want to use this equation here to obtain y, it's still your choice. I have decided to use equation 2 to be faster for me. So coming to equation 2, it implies that 5 times, I'll put minus 1 for x here, then minus y that I'm looking for equal to minus 8. Solving this, alright, if I take this minus y to the other side of the equation, and bring this minus 8 to this to meet its like term, 5 times minus 1 will give us minus 5. Then minus 8 crossing will give us plus 8. Minus y going to the right will give us positive y, okay? So minus 5 plus 8, what will you get? 3. So you see that y is equal to 3. Therefore, the coordinate of this point, which we now call x2, y2, is equivalent to minus 1, 3. So that is the coordinates of this point of intersection. We shall use this coordinate now and this point to obtain the equation of a straight line. It simply means that the line whose equation we are about to obtain passed through something like this, where this point is 2, 2, giving us x1, y1. And then the second point we obtain minus 1, 3, giving us x2, y2. So we shall use the equation. Remember, if a straight line passed through 2 points and the coordinates of the 2 points are given to you, you're going to use the equation y minus y1 equal to m x minus x1 to solve it. We actually solved something like that in our question number 2. So I will substitute y minus y1 is 2 equal to this y1 equal to m is now given as y2 minus y1 all over x2 minus x1. Is that not so? So y2 minus y1 is 3 minus 2. All over x2 minus x1 will give us minus 1 minus this 2. Then bracket x minus the value of x1. And the value of x1 is what? 2. So simplify this, let's see what we get. This is y minus 2 equal to, the numerator will give us 1, denominator will give us minus 3. Open bracket x minus 2. Clear fraction, so you're going to multiply through by minus 3. If you're doing that, minus 3 times this 1 will give us what? Minus 3, 1. Then minus 3 times minus 2 will give us plus 6. That will be equal to 1 opens up this bracket, you're going to get x minus 2 there. Alright? So collect all terms together and then equal to 0 if you wish. So to make this y positive, I want to take it to the other side. So I want to move everything to the other side of the equation. So it's going to be 3y there. Now you have plus x over there. Remember, if this plus 6 crosses, it becomes minus 6 here. So minus 2 minus 6 will give us minus 8 equal to 0. So this is the equation of this new line. This is the required equation we are looking for. We have this question number 4 on the board. We have to find the equation of the straight line which passes through the point minus 2, 1 and parallel to the line y minus 3x equal to 2. What should we know about this question? Point number 1 is that it passes through the point. Let's say x1, y1 equal to minus 2, 1. So this is the point the line passed through. We also should know that the line's equation we are to get is parallel to this line that has this equation. Okay? Which means, alright, if we have this line defined by the equation y minus 3x plus minus 3x equal to 2, the line we want to get is parallel to this. They are parallel. Now, if they are parallel, what does it mean? It means that their gradients are equal. Take note of that, write it down. When two lines are parallel, they have equal gradients. This is our line that passed through the point, minus 2, 1. Is that okay? This one. So we want to get the equation. But we know that it is parallel to this. So what we are going to do is to get the gradient of this line. And we know now that that gradient of this line is equal to the gradient of the new line whose equation we want to find. Once you get the gradient, the problem is solved. You can now use the equation of a straight line y minus y1 equal to n bracket x minus x1. You know your x1, you know your y1 already. So you know that your problem here is to get the gradient. So how do we now obtain the gradient of this new line? It's equal to the gradient of this old line here. So we are going to standardize this equation. If you want to obtain gradient of a line from a given equation, you standardize that equation by doing what? Making y subject of the formula. So you watch. I'll come to this equation, I'll say that y is equal to this 3x, we cross over it, become 3x plus 2 there. Then compare it with this equation of the straight line in slope-intercept form, mx plus c. You take note that our gradient n is the coefficient of x here, so therefore the gradient of the line we want to get, n is equal to 3. If you compare. What is the intercept here? Intercept is 2, take note. Anyway, let's focus on our problem now. We now want to get the equation of this line. So we can now write y minus y1 is equal to n x minus x1. So we substitute y minus y1 is what? 1 here. Equal to the gradient is 3 we got. Then x minus, our x1 is what? Minus 2. So minus 2. If you solve this, you have y minus 1 equal to 3 bracket x plus 2. You know, minus times minus is plus. So this will give us y minus 1 equal to 3 times this is 3x plus 6. 3 times 2 is 6. You can choose to make y something formula, so it's going to be 3x. If this minus 1 crosses, it becomes plus here, so 6 plus 1 will give us 7. So this is our result, okay? Or you can choose to pick everything to one side. You have y minus 3x minus 7 equal to 0. This is still an alternative answer, your choice. So this is the equation of this line, which is parallel to this and passes through the point minus 2, 1.